Good morning. I'm Dr. Jyoti Kumar. Today we will discuss about the topic a cache coherent problem. Since we have private caches, how to keep the data consistent across the cache. Each core should perceive the memory as a monolithic array and shared by all the core. Here I have four core 1, core 2, core 3 and core 4, and we have one or more levels of a caches for each and every core, and it is connected to a main memory. It's a common shared memory. Here suppose the variable x initially consists of 15213. This is the variable x which is in the main memory, and the value is 15213. And we have, as I mentioned, we have core 1, core 2, core 3, and core 4. Each core is connected with the cache, maybe of level of cache. Okay. Now, the core 1 reads the x. So the value of x, which is 15213, is reflected in the cache of the core 1. X, which is equal to 15213. Next, when you see core 2 read x, yeah, again the value of x is 15213. So the core 1 also contains 15213 and core 2 also contains 15213, since the main memory the value of x which is equal to 15213. And core 1 writes to x, setting it to 21660. So the value of the core is going to write the value of x in its cache as 21660, and it absolutely reflects in the main memory. So the value of x in the main memory is 21660, but there is no change in the cache of core 2. The value of x is 15213 here. And then core 2 attempt to read x, get a stale copy. Again, there is no change in the value of x in core 2. So the solution of a cache coherence, this is a general problem with a multiprocessor, not limited to just a multi-core alone. There exist many solution algorithms, cache coherent, cache protocols, etc. A simple solution, invalidation based protocol with snooping. So here is this. We have, as I mentioned again, in intercore buses, I have intercore buses. That bus is connected with the shared memory, and each and every cache is connected to the bus. Each and every core cache is connected to the bus. Here, invalidation. If a core writes a data item, all other copies of the data item in other caches are invalid. If a core writes a data item, all other copies of the data item in other caches are invalid. So when the value of x, which is change in the core 1's cache memory, all the other data, all the other same data which is present in the other cache is said to be invalid. Coming to snooping, all cores continuously snoops or monitor the bus connecting to the core. So snooping refers to the monitoring. So it monitors the bus connected to the core. So we may have a chance to float an invalid signal, or we may have a chance to update the value of the core cache also. Coming here, revis core 1 and core 2 has both read x. Yeah, the main memory contains x equal to 15213, and again this reflects in cache 1 of core 1 and cache of core 2 also. So both are same. So the core 1 writes value of x and setting it to 21660. Yes, it happens. Main memory value is 21660, and so it reads the value, or it writes the value 21660. So the value of x is. Since there is a change that occurs in the cache of core 1, right, we are going to float an invalidate request in the bus. So since we are floating invalidation request, so the value of the same data which is given which is in the other cache is invalidated. The same data which is present here in the other caches is invalidated. So the value of x is 15213 is not valid since we are sending an invalidate request. After invalidation, the bus identifies the value of x is 21660. So this is an updated value. Since the value was snooped by the particular monitored by the bus, so the value of x is 21660, and this is exactly reflected in the cache of the core 2. So snooping, okay, identifies the value of x which is equal to 1660.